So, have you ever wondered how ChatGPT actually knows that the word cat is really closely related to kitten, but has pretty much nothing to do with airplane? I mean, it kind of feels like magic, right? But listen, it's not a magic trick, and it is definitely not just guessing. It all actually boils down to a single, surprisingly simple mathematical operation that gets repeated literally billions of times inside every single large language model. That operation is called the dot product, and in this explainer, we're going to unpack exactly how it works.
All right, let's just dive right into this. Here is our agenda for today's whiteboard math explainer. First, the secret math of AI. Number 2, visualizing the dot product. 3, the formula in action. 4, powering modern AI. And 5, mistakes and key takeaways.
Okay, part 1, the secret math of AI and how vectors actually compare.
To set the stage here, you have to remember that AI represents absolutely all information. Words, images, sounds, you name it, as vectors, which are really just big lists of numbers. But just storing that data, that's not enough. Which brings us to our core mystery for today. Given two vectors, how similar are they? Like, do they point in the same direction or not? We need a mathematical way to compare them, kind of like checking a dating app compatibility score, right? We need an operation that takes two vectors and just spits out a crystal clear answer about their relationship. Moving right along to section 2, visualizing the dot product and its 3 states of alignment.
Before we even touch a single formula, let's just build some really powerful visual intuition. Imagine two arrows on a grid. First, if they point in the exact same direction, they totally agree, which gives us a large positive value. Second, if they are perpendicular, meaning they form a 90-degree angle, like an L shape, they are completely unrelated. In that case, the dot product is exactly 0. They share absolutely nothing in common. And third, if they point in opposite directions, they disagree, resulting in a negative value. So just by looking at the sign and the size of that one single number, the AI can instantly understand the relationship between two wildly complex pieces of data.
Let's move over to section 3 now and see how this actually builds mathematically in our formula in action segment.
Okay, here is the underlying mathematics, and I promise you, this is literally just basic arithmetic. The formula is A dot B. A and B are our two vectors. A1 is the first number in vector A, and B1 is the first number in vector B, and so on. The rule is incredibly simple. It's basically elementary school math. You just multiply the matching positions together and then add up all the results. That's the whole thing. Let's actually look at some real numbers to prove this.
So here's our first example. Vector A is 2, 3, and vector B is 4, 1. Step 1. We multiply the matching positions. 2 times 4 gives us 8. 3 times 1 gives us 3. Step 2, add those results together. 8 plus 3 equals 11. Boom, that's it. 2 vectors went in and one single number came out. And because 11 is a nice, solid, positive number, we know these two vectors are highly aligned and pointing in roughly the same direction. Now let's test that perpendicular case we talked about earlier. Imagine vector A is pointing flat to the right at 1, 0, and vector B is pointing straight up at 0, 1. Let's just run the math together. 1 times 0 is 0. 0 times 1 is also 0. And 0 plus 0 is, well, 0. A massive, undeniable 0. This proves completely mathematically that perpendicular vectors share absolutely nothing in common. The math perfectly backs up our visual intuition from earlier. And finally, let's check out the opposite direction case. Vector A is 3, 2. Vector B points completely backwards at -3, -2. We quickly multiply the matching positions. 3 times -3 is -9. 2 times -2 is -4. Add them up, and -9 plus -4 gives us -13. A highly negative result of -13. This tells the AI, loud and clear, that these vectors point completely away from each other and strongly disagree. So, just to recap, multiply matching positions. Add them up. That is literally the whole secret. Which brings us nicely to section 4, powering modern AI. Because now we're going to shift from basic math to showing how this exact same super simple arithmetic is the actual beating heartbeat of modern large language models.
And this brilliantly illustrates embedding similarity, which completely answers our very first question about ChatGPT. Remember, words are just vectors. Look at the math for cat and kitten. Behind the scenes, their matching features are multiplied, say 0.9 times 0.8 to get 0.72, and 0.1 times 0.2 to get 0.02. Then they're added together. 0.72 plus 0.02 equals a positive 0.74. The model sees this positive number and just immediately knows the words are related. But now look at cat and airplane. The underlying multiplications just cancel out. 0.9 times negative 0.1 gives us negative 0.09, and 0.1 times 0.9 gives us positive 0.09. Added together, that equals a flat zero. The numbers themselves mathematically prove that cat and airplane are completely unrelated.
Okay, now here is a massive secret in AI. If you've ever studied neural networks, you have absolutely heard of a weighted sum. Well, look at these inputs, 1.0, 0.5, and 2.0. Look at the weights, 0.3, negative 0.2, and 0.7. If you multiply the matching pairs and add them up, you get 0.3 minus 0.1 plus 1.4, which equals 1.6. Guys, the famous weighted sum inside every neural network is literally just a dot product wearing a different name. It's the exact same math. It is also the absolute core of transformer attention, which is what powers GPT models. Basically, every word has a query vector and a key vector. So in the sentence, the dog chased the ball in the park because it was fast, how does the AI actually know what the word it refers to? Well, it just runs a dot product. It multiplies their matching vector features and adds them up. For the words it and dog, multiplying 0.6 by 0.7 and 0.8 by 0.6 gives us 0.42 plus 0.48, resulting in a massive score of 0.90. But it and park calculates out to negative 0.30 plus 0.16, giving a negative 0.14. Because of that math, the word it pays super high attention to dog and completely ignores the park. This simple arithmetic is exactly why AI tools can translate languages or summarize your emails with such unbelievable accuracy.
All right, let's head into Section 5, Mistakes and Key Takeaways, so we can wrap up our mathematical journey here and definitely clear up a major beginner misconception.
So, the absolutely crucial point here is this. The dot product does not just multiply vectors to create a new vector. Look at side A. If you just multiply position by position, you get 8 and 3. That makes a brand new vector, 8, 3. That is completely incorrect. The true dot product, shown on side B, goes that one step further and adds those numbers together into a single standalone number, in this case, 11.
That standalone number is what we call a scalar. And the magic is, whether your vector has 2 dimensions or literally 12,000 dimensions, the dot product always collapses it down to one simple number. And that's exactly why AI loves it so much. It turns a wildly complex question like how similar are these two massive abstract concepts into one single simple number that the computer can easily rank and sort.
Well, we've covered some incredible ground today. We now know exactly how to measure the direction and similarity of vectors using the dot product, but this actually leaves us with a totally fascinating unanswered question. How long is a vector exactly? Does the actual length of these arrows matter as much as their direction? Keep that provocative thought in mind, because that is exactly what we are going to uncover in our next explainer. Thanks so much for learning with me today.